This is a lecture from OpenTuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
In the last chapter we did high-low, which you should have found very straightforward indeed. In this chapter, in this lecture, I'm going to do learning curves, which is something completely different. So let me just for a moment explain what it is we're getting at. Suppose we were thinking of producing a new product. We make desks, we decided to produce a new type of desk. We've never made one before, but of course I want to try and estimate what the cost will be, because we're going to start selling as soon as we start making. I need to estimate a selling price. Well, I've never made one before, so how can I estimate how much the cost per unit is going to be? The obvious thing to do would be to make one and measure the costs. So I make one unit, and I can measure how much wood and cost it out and everything. I also need to know the labour. Well, they've made a unit, but they've never made one of these before, and so it took them a very long time. It took them 100 hours to sort out this one unit. Well, of course it took them a long time. I don't know if you've ever made a desk, but I'm sure if I gave you one to make, it would take a long time. But we're going to end up making thousands of these. And surely, even though you'd expect the first one to take a long time, as you make more, would you not expect usually to get faster? You get better at it. They're all going to be identical desks. So the first one might take you 100 hours, but the next one might only take you 50 hours. The third one might only take you 10 hours. We'll get faster. Now, it would surely be stupid to base our selling price simply on the cost, therefore the time it took for the first desk. If we know that even though that took 100 hours, if we know we're going to be able to make the desks in 1 hour each, when we've done a few of them, we should base the cost on the 1 hour it's going to take, and therefore the selling price. Well, learning curves, there's a rule and later a formula, which lets us estimate how long it will take as we make more and more of the units. The first one may take 100, the second one may only take 50, the third one may only take 30, and so on. Well, there's a way we can estimate. Now, I'm going to jump over the second page for a moment. I'll come back to it later. And if we go straight to the third page, you'll see paragraph 3.2, theory. The rule is that as cumulative output doubles, the cumulative average time per unit falls to a given percentage of the previous average time per unit. Now, all right, that's the rule, but you could read that 20 times and it means nothing. Let me show you how it works using example 2. It says the time taken to produce the first unit is 100 hours. There's a learning rate of 75%. We can discuss later where that may come from, but that's telling us how fast they learn. How long will it take to produce an additional 7? Okay, now let me show you how it works, and watch very carefully. It's not hard, but far too many people half learn this and end up with stupid answers. I'm going to set it up as a little table. The total units, average time per unit, total time. We start off, we say, if we make one unit, the total time to make that unit is 100 hours. And it may seem silly for the moment, be patient with me, but if you only make one unit and it took 100 hours, the average time per unit is 100 hours. Now, the way the rule operates, it says if we double production, So double production means that we make an extra unit, we double up to 2. If I make 2 units, the average time for those 2 units, the average time per unit, is the average time for the one before, 100 hours, times the learning rate of 75%. The average time per unit falls to this percentage here, 75% of the previous average time. But so importantly, that is not the time for the second unit. That's the average time per unit if you make 2. If you make 2 and the average time per unit is 75, the total time is 150. So the total time to make 2 units is 150. And if I wanted to know how long the second one took, I know the first one took 100 hours. I know to make 2 will take 150 in total. And so in fact, the second unit took 50 hours. So do see what I'm saying. We're going to carry on with this, but do see what I'm saying. This does not directly give you the time for the second unit. Here, the first unit takes 100, the second unit takes 50. But the average time per unit is 75. It's fallen 75% of the previous average time. And the rule keeps continuing. So we've now made 2. If we double again, if we make another 2, we double up to 4. And although each unit's getting, first 100, second 50, they're all getting faster and faster, the learning rule tells us what the average time per unit will be if we make 4. It's 75% again of the previous average time, which is 56.25. Now again, that is not the time for any one unit. It's the average time per unit if we make 4. So the total time to make 4, if it's 56.25 on average, the total time is 225. Well, we know that the first 2 took 150 hours in total. If to make 4 takes 225 hours in total, well, the difference of 75 is the time for those next 2, for the third and the fourth together. So first one takes 100, second one takes 50, third and fourth together takes 75. And in fact, one problem with the basic rule is it doesn't tell us how long number 3 took, how long number 4 took. 75 in total, so I don't know, number 3 may have taken 45, number 4 may have taken 30, but we don't know. And we can carry on forever, keep doubling. Let's do it just once more. We've made 4 in total. If we double, we'll make another 4, we're up to 8. And again, they're going faster and faster and faster, so the average time per unit will be lower. It'll be 75% of what it was before. 56.25 times 75%, 42.1875. And so what's the total time to make 8? 8 times that. 8 times 42.1875 is 337.5. But for the last time, that 337.5 is the total time to make the first 8. I know the total time to make the first 4 is 225, so the total time to make another 4 is the difference. But this rule only works with doubling. I can find, and I know how long it takes for numbers 5, 6, 7, 8 in total. But this rule won't let me calculate how long for number 5, how long for number 6, how long for 7. But do check you've understood the rule. Because although, obviously, I would like to know how long number 3 took, how long number 4, and there is a formula we can use. Whether you find the formula easy or difficult, you can specifically be tested on the doubling rule. You must make sure that you're happy with what I've done. Now, I was there illustrating how the rule works. In fact, if you look back to the question, we haven't quite answered it. It says, how long will it take to produce... Sorry, start again. We've made the first unit at 100 hours. How long to produce an additional 7 units? Well, although, in fact, the answer's there. If I was trying to do that as fast as I could, watch the way I would set it out, and it's relevant to what's coming. The time for an additional 7, you cannot work out directly. All you can do is say this. If we've made 1 and we've made an additional 7, it'll be 8 in total. And so we can work out the total time for 8. And if I know how long it takes to make 8, if I subtract the time for the first, then surely the difference will be what the question asks for. That'll be the time for an extra 7. How long's the first one? That's no problem, of course, 100 hours. How am I going to get the total time to make 8? Well, it'll be 8 times the average time per unit. And how can I work out the average time per unit? Well, I wouldn't waste time setting up everything I did before. I'd simply do quickly, 1 unit was 100. Double is 2 units. 75%, 75. Double again is 4 units. I know I did before, I'm not going to wind back. 75% is 56.25. Double again is 8 units. 75% is 42.1875. So once you've got the hang of it, you can do that pretty quickly. And so the total time for 8 times the average time. The average time is 42.1875. And therefore, the total time multiplied by 8 is 337.5. And so, what's the answer? 337 in total, 100 for the first. The time is 237.5. Now, sorry, don't misunderstand me. I know we've done all those workings earlier. But, I was going step by step to try and explain the rule. In the exam, you don't have to waste time. That would be your approach. Okay, well, there's the doubling rule. But the big problem is it only works when we double. What happens if I'd given you exactly the same question, but instead of saying, total time for the next 8, I'd said, what's the total time for the next 5? Well, you made 1. If you make another 5, you'd have to take the total time for 6, less the time for the first. But how do you get the total time for 6? Because we can only, using the rule, we can only get the average time per unit when we're doubling. So you can do it for 2, 4, 8, 16, 32. But, I won't tell you go that far. But if ever it keeps doubling, we're okay. But, how long for 10? How long for 15? And so on. And so, as I did quickly mention earlier, although you must know the doubling rule, you could be specifically tested on it. To deal with a situation when it's not doubling, there is a formula. And the formula is printed in paragraph 3.5. And it's on the formula sheet. You don't need to learn it. But the formula, y equals ax to the power b. This formula, I'm obviously about to illustrate it with an example, but y is the average time per unit A is the time for the first unit, X is the number of units, and B is the learning factor, but you're also given the formula for B. It's the log of R over the log of 2, where R is the learning rate. Now, I'm about to illustrate, but two things. One is B. I think I'm right in saying you have never actually been asked to calculate B. It's always been given in the exam. But you could be asked to calculate. And so you've got to make sure that your calculator, there is a log button. You don't get given log tables. And you don't need to understand logs. This is the only place logs appear anywhere, so we're not going to have a lecture on logs. Basically, you just need a log button. If you don't have a log button while you're watching the lecture, then when you have got a calculator with a log button, then go back and have a go at the example yourself and see if you get the same answer as me. Anyway, let me show you how we use the formula. Let's look at example 3. Flogel has just produced the first full batch of a new product taking 300 hours. The learning curve effect is 85%. How long, two parts here. Part A, how long will it take to produce the next 15? Now be aware of this in the exam. It's very similar to the earlier one. We've made one, we're going to make another 15, which will mean 16 in total. And so, let's approach it in the same way. To get the cost of the time for the next 15, we'll take the total time for 16 less the time for the first. We know the time for the first is 200 hours. The total time for 16 is 16 times the average time. Well, the point I want to make here is always pause and think that although I've yet to show you how to use the formula, I don't care how good you are in your calculator, but personally, I think this is better than doubling. It's quicker. Because having your head, doubling will do for 2, 4, 8, 16. This is the doubling one. So I've still not shown you the formula. I'm not going to until part B. But let me work out the average time for 16. It's 1, 2, 4, 8, 16. The time for the first is 200. Keep multiplying by, it's 85%. So the average time for 2 is 170. Keep it in your calculator, multiply by 85% again. 144.5. Again. 122.825. And one more time. 104.401. Don't worry about a bit of rounding here. You won't lose marks for rounding within reason. I would always go to 2 decimal places, but you're not going to lose rounding marks. But the point is, having doubled it 1, 2, 3, 4 times, we get 104.401. That is the average time per unit if we make 16. So the total time, if we make 16, is 16 times the average. And now we've got it. 1670.42. Time for the verse was 200. So it's 1470.42. For the next, however many it was, 15. All right, well, still haven't shown you how to use this formula, but you know, that was part A. But now look at part B. Now read this carefully because this is very typical for the exam. Flogel expects that after the 30th batch has been produced, the learning effect will cease. Now, think about it. We've so often been through the idea that you get faster and faster and faster the more you produce, but there will come a limit. You know, it may take 100 hours to make the first unit. You'll get faster and faster, but maybe once you get down to 5 hours a unit, well, you're not going to get any faster. You've gone as fast as you can. And they expect that after they've made 30, the learning effect will stop. And so from batch 31 onwards, they'll all take the same as batch number 30. So if batch number 30 took 5 hours, then from then on, they'll all take 5 hours. And if they're all going to take 5 hours once we've done our learning, well, that's the time we should budget. So what do I need to know? I need to know how long batch number 30 will take. We can't do it directly. All we can ever do is work out the total time for a number of batches. So I can work out the total time for 30 batches. But I wanted to know the total time for number 30. So we'll have to subtract the total time for 29. And if we can get that, that'll give us the time for the 30th. So same idea as before, but 30 and 29 don't involve doubling. Remember, it's 2, 4, 8, 16, 32. So we can't do doubling here on either of them. Now, it is going to be the same principle. The time for 30 will be 30 times the average time. But the only way you can get the average time if we make 30 is using the formula. So let me show you how we use the formula. And I'll go back and finish it off. I've already given you the formula, y equals x to the power b, or you've got it printed in front of you. But we do need, first of all, to know what b is. B is the log of r over the log of 2. R is the learning rate, 85%, but expressed as a decimal. What I mean is, instead of 85%, we express it as 0.85. Divided by the log of 2. Now I've said, whether you've got one in front of you at the moment or you haven't, you must get a scientific calculator that can do this. And if you're efficient, you should be able to do both steps in one, and use brackets and things, but just so that everybody can check it, the log of 0.85 log is minus 0.070581, divided by 2 log 0.30103. Incidentally, on mine, I put 2 and then press the log button. Different calculators have different orders of how you put things in. You're going to have to, if you're not sure, you're going to practice to look at the manual. But if I divide 0.070581 divided by 0.30103, I get minus 0.2345. And we normally write this to 4 decimal places. Now, I did say earlier, it is extremely unlikely that you would actually be asked to calculate it. So far, questions have always told you what B is. And then say, don't go checking the examiner. If the examiner says it's minus 0.2345, you used to put 345. One thing to be careful of, though, whether you calculate it or whether you're given it, it is always negative, always. Any of you ever done logs before? Because the top of the equation is always the log of a number less than 1. The log of a number less than 1 is always negative. And it's vital for what comes next. So, you know, you would almost certainly be told B is minus 0.2345. You might not notice the minus. It's always negative. Having got that, or being given it, then we can use the main formula. But remember, I want the average time for 30. Well, the average time will be equal to A, the time for the first, which was 200, times X, which was the number of units, which is 30, to the power minus 0.2345. Now, this bit of calculator work, you must make sure you can do. If you have problems, you must practice. Again, when you're efficient, do the whole thing on your calculator, but it's the second bit that's the problem. Being able to take 30 to the minus 0.2345. And again, unfortunately, different calculators do it differently. We get the same answer. Certainly in my calculator, I have a button on it which says x to the power y. I'm going to use that. Now, I'll tell you what I need to press on my calculator in a minute. But 30 to have a go, and then if you can't sort it out, I'll write down what I key in. But 30 to the power. It actually comes to 0.4504. Now, I'll finish that off in a second. That's no problem. But I will tell you what I key in on mine. But the trouble is, calculators have 2 types of what they call calculator logic. Some do it the way mine calculator does, some do it a different way. And so, as I say, if you're having problems, it's a question of practice and looking at the manual. If you've lost your manual, search it up on Google or something. Because once you've got it, it's easy. But on my calculator, I have to do this. I key in 30, obviously. Then I hit the button x to the power y. And then I key in 0.2345, but without the minus sign for the moment. The trouble is, if I put minus 2345, all it does is subtract it. I then have a button with a plus minus on it. And so although I didn't type the minus sign in, pressing plus minus puts the minus sign there. And then I press the equals button. So I can't say any more than that. If your calculator has the same logic as mine, that'll work. If it doesn't, well, I've said enough. I wrote that down separately. Of course, in the exam you don't need to. Once you've got that on your calculator, you can just multiply by the 200. I get 90.08. Now be careful again, some people get so excited that they've got that far, they forget what it is. That's the average time per unit if we make 30. So the total time for 30 will be 30 times that. The total time for 30, therefore, 270.24. But of course, I also need the total time for 29. That'll be 29 times the average time for 29. So we do it all over again. But in fact, when you've done it once you've got it, it's actually very quick. It doesn't take too long. What's the average time if we make 29? Well, again, the average time equals ax to the power b. A was the time for the first unit, 200. X was the number of units, which this time is 29. And b, of course, even if you had to calculate it, you don't need it to calculate it again, it was minus 0.2345. And I'm not going to talk button by button this time. I'll say again, once you've got it for one, you can do it for any. But 29 to the power 0.2345 negative equals 0.4540. And this time I won't, I'll just multiply direct by 200. I get 90.80. Again, that's the average time per unit, so the total time for 29 is 29 times 90.80. 2633.20, I think. Oh, good heavens, it can't be. Let me check again. 29 times 90.8. Did I do the first one right then? Obviously, I made a mistake on the first. Sorry, I bet some of you have been sat there for the last 20 minutes cursing me. Sorry. However, the time for the 30th the difference 69.2 hours. And does that make sense? Of course it does. You see, it got faster and faster and faster. On average, for 29, it was 90.8 hours. Make 30, the 30th is 69, so the average went down a little bit to 90.08, but whatever. There's the time for number 30. And from then on, everything we produce will take 69 hours, and therefore, sensibly, that's the time I would use in any budgeting. If you go back to the previous page briefly, if I can find it, you will see a mention of conditions. And do have a read through those. But the main thing is, most importantly, for learning to work, first of all, it's labour. It's labour. I mean, machines don't learn. It's labour that learns. And secondly, it does assume that we're keeping the same workforce. If you've got, if workers keep changing, then new workers have to start learning all over again. This learning is only going to apply provided it's a steady workforce producing a steady product. I don't think I need to say any more. Okay, so sorry about that tiny mistake there, but it's correct now. But there we are, the learning curves. Do have a go at the online multiple choice question test and see how you get on.